Hello everyone, this is Group 2 and we'll discuss Chapter 5-3, Staffing a Call Center. I introduce my name, I'm Kendrick, and I'm with my groupmates Christopher, Ethan, Kylle, and Richenza. I will present the case facts of this case study. Number 1 is the call volume variability. The call center experiences significant variability throughout the day, week, and peak seasons. Second is the employee scheduling. The call center uses a combination of full-time, part-time, and temporary employees. Scheduling of account staff depends on their accountability. The cost, the business must control labor expenditures while guaranteeing adequate staffing to handle call skills. And lastly, the training of employees. Training has an impact of staffing because employees are not accessible to receive calls during training sessions.
Now we delve to the problems about the California Children's Hospital regarding its appointment and registration procedures. These challenges have catalyzed the hospital's decision to pursue a centralized call center solution. So let's begin figuring out the critical issues prompting this strategic shift. California Children's Hospital has encountered significant operational hurdles due to its decentralized approach to appointment and registration services, and then these problems include operational inefficiencies. The hospital's decentralized system requires parents to navigate multiple departments independently, resulting in confusion and delays in scheduling appointments of registrations. Next is information accessibility. Essential contact details for various clinics and departments are inconsistently available, complicating the patient experience and increasing administrative burden. And then communication gaps. Interdepartmental communication breakdowns lead to missed referrals and redundant contacts from patients, underscoring the need for improved coordination. So, to address these problems effectively, the hospital is implementing a centralized call center, and this initiative aims to streamline operations and enhance communication and improve overall patient satisfaction. And then to guide their staffing decisions or the call center, the hospital is leveraging spreadsheet modeling. This approach allows them to forecast call volumes and determine optimal staffing levels for each shift, and balancing operational efficiency with cost effectiveness. And then creative chaos consultants have meticulously forecasted call volumes expected at the call center across different shifts, and these forecasts serve as the foundation for the spreadsheet models that will inform staffing decisions, ensuring adequate coverage while minimizing operational costs.
For inputting the data, since 20% of the calls were from Spanish speakers, we decided to input the data into two separate tables. So for the columns, they are separated by the operators who will spend their first shift answering phone calls in their respective languages. So that would be English or Spanish. And then for the rows, they're separated by the different hours of operation. So for the cost, since the problem gave us two different hourly wages depending on the time of day the operators are working, we have different values in the costs. So we took the different hourly wages depending on the time of operation and multiplied it by whether or not they were full-time or part-time employees, because for part-time they could only answer phone calls and they will spend the whole 4 hours of their shift. So to get the 60s, we multiplied 15 by 4, and then for 66 we multiplied 15 by 2 and then added 18 times 2, and then for 72 we got it by multiplying 18 and 4.
The formula we used in this case analysis would be as follows. In each table, commonly the first row and column of each table would be the shift of operating operators, which is the time. And in between these, the blue highlighted cells are the number of operators in each shift in English, Spanish, or in both languages. The constraints commonly are the total and the required number of operators. Commonly, to get the total costs in Solver, the set objectives would be the total cost, and the changing variable cells would be the solution, and the constraint would be the total and required number of operators. If done manually, it would be commonly the total number of operators in each time shift. For example, 7 a.m., which is 5 in the first table, multiplied by 60, and you add that until the end of the, you repeat that process until the end of the uh, time, which is 7 p.m. to 9 p.m., you would get the total cost of each table.
Moving on to the case questions. The number of operators that the hospital needs to staff the call center during each 2-hour shift can be found in the following table. To give an example on how this is computed, let us take for the 7 a.m. to 9 a.m. shift. For example, the average number of phone calls per hour during the shift from 7 a.m. to 9 a.m. equals 40. Since on average 80% of all phone calls are from English speakers, there is an average of 32 phone calls per hour from English speakers during that shift. Since one operator takes on average 6 phone calls per hour, the hospital needs 32 divided by 6, which is equal to 5.333 English speaking operators during that shift. The hospital cannot employ fractions of an operator and so needs 6 English speaking operators for the shift from 7 a.m. to 9 a.m. The problems of determining how many Spanish-speaking operators and English-speaking operators Lenny needs to hire to begin each shift are independent. Therefore, we can formulate two smaller linear programming models instead of one large model. We are going to have one model for the scheduling of the Spanish-speaking operators and another one for the scheduling of the English-speaking operators. The following spreadsheet describes the entire problem formulation for the English-speaking operators. This spreadsheet describes the entire problem formulation for Spanish-speaking operators. Lenny should hire 24 full-time English-speaking operators. Of these operators, 6 have their first phone shift from 7 a.m. to 9 a.m., 12 from 9 a.m. to 11 a.m., 5 from 11 a.m. to 1 p.m., and 1 from 3 p.m. to 5 p.m. Lenny should also hire 6 part-time operators, 2 of which who start their work at 3 p.m. to 5 p.m., and 4 operators from 5 p.m. to 7 p.m. In addition, Lenny should hire 10 Spanish-speaking operators, with 2 having their first shift at 7 a.m. to 9 a.m., 3 from 9 a.m. to 11 a.m., 2 from 11 a.m. to 1 p.m., and 1 p.m. to 3 p.m., and 1 from 3 p.m. to 5 p.m. The total wage cost of running the center equals to $2,460 per day. Lenny should hire 25 full-time English-speaking operators. Of these operators, 6 have their first phone shift from 7 a.m. to 9 a.m., 13 from 9 a.m. to 11 a.m., 6 from 11 a.m. to 1 p.m., and 1 from 3 p.m. to 5 p.m. Lenny should also hire one part-time operator who start their work at 3 p.m. and four operators who start their work from 5 p.m. The hiring of Spanish-speaking operators is unaffected. With that, the new total wage cost equals to $1,830 per day. For each hour, we need to divide the average number of calls per hour by the average processing speed, which is 6 calls per hour. The number of bilingual operators that the hospital needs to staff the call center during each 2-hour shift can be found in the following table. The linear programming model for Lenny's scheduling problem can be found in the same way as before, only that now all operators are bilingual. Lenny should hire 31 full-time bilingual operators. Of these operators, 7 have their first phone shift from 7 a.m. to 9 a.m., 16 from 9 a.m. to 11 a.m., 6 from 11 a.m. to 1 p.m., and 2 from 3 p.m. to 5 p.m. Lenny should also hire 6 part-time operators who start their work at 5 p.m. The total wage cost of running the call center equals to $2,268 per day. To recap, monolingual wage cost is $2,460 per day and bilingual wage cost is $2,268 per day. Lenny could pay an additional $192 in total wages to the bilingual operators without increasing the total operating costs beyond those for the scenario with only monolingual operators. The increase of $192 represents a percentage increase of 8.47%.